All right, let's go over first few of these. Maybe let's do 1 through 6. So questions 1 and 2. So the first part of this is just writing a balanced equation. So this is something we've done before spring break. You have to know a few things in order to do it. So this is some good practice. So let's go ahead and do step 1. Step 1 is in reference to our question 1. And it says if 1 gram of barium chloride reacts with 1 gram of sodium sulfate, how much of the precipitate will form? So that precipitate gives you a clue. This is a double replacement reaction. So both the barium chloride and sodium sulfate are dissolved in water. We're going to mix them together and we're going to see if a solid forms. So a couple of things. First off, barium chloride. If you have to, you can reference your periodic table to see that barium is a +2 charge. Chloride is in reference to chlorine, which is a -1 charge, so we need 2 of those. And then that's going to react with sodium sulfate. And sodium is a +1 charge, and sulfate, if you don't remember the charge, you can refer to the back of your periodic table, and you'll see it's -2. So we're going to need 2 sodiums to get a net charge 0 with that sulfate. Now, when these are ions floating around in solution, so barium ions, chlorine, sodium, and sulfate ions, there's the chance that barium and sulfate could pair up to give us barium sulfate. And there's the chance that sodium and chlorine could pair up to give us sodium chloride. Now, sodium chloride, you know, is table salt, and if we dissolve that in water, it just stays dissolved as ions. But if we look at the back of our periodic table and we see barium and we go over to sulfate, that forms a solid. So barium sulfate is our precipitate or our solid in this one, right? Barium sulfate, that is our solid. Now it says calculate the molar mass of each compound you will need to use. Well, it's telling us we have 1 gram of sodium sulfate. It's also telling us we have 1 gram of barium chloride. And then it's asking us about our precipitate, which is the barium sulfate. So let's find the molar mass of all 3 of those. So barium chloride, if we look at our periodic table and we see barium, at least on mine, it's 137.328. If you have yours that I gave you in class, it might be a little bit different. But after we calculate, it should be pretty much the same. So 137.328 for the barium. The chlorine, 35.453, and we have 2 of those, so we'll have to multiply that by 2. So when we do the 2 chlorines and the 2 chlorines and the 1 barium, we get around 208.23 grams per mole. For the sodium sulfate, Na2SO4, we have 2 sodiums. Sodium on your periodic table is 22.99. We have 2 of those, so you have to do that twice. 1 sulfur, 32.06, and then 4 oxygen. Oxygen is roughly 16, so you're going to have to multiply that by 4. Add all that together, and you should get something around 142.05 grams per mole. And the very last one, barium sulfate, BaSO4. I'm going to have to write this below here. BaSO4, when you add all those, the barium, the sulfur, and the 4 oxygen, you're going to get something around 233.4 grams per mole. All right, so now we have the molar mass of all 3 of those. Barium chloride, sodium sulfate, barium sulfate. All right, so now it says solve for the quantity of the precipitate for both reactants. Now this is where this step is where it's a little bit different than anything else we've done. Because up here it's asking, what if I have 1 gram of each? Well, it is possible that 1 gram of this would allow me to produce more barium sulfate if I had as much of this as I wanted. Or vice versa, if I had as much barium chloride as I wanted, but only 1 gram of sodium sulfate, I might produce a different amount of barium sulfate. All right, so let's make sure our reaction's balanced first. I do notice there's 2 sodiums here and 2 chlorines, so I'm going to put a 2 right there. Everything else would just be a 1, even though we don't write the 1s. So it's just a 1-1 ratio except for that sodium chloride there. But we're not actually going to be doing anything with that sodium chloride. So for this first one, let's start off calculating how much barium sulfate I would produce with 1 gram of barium chloride. So if I had 1 gram of barium chloride, all right, 1 gram of barium chloride, and remember my next step, I got to convert grams of barium chloride into the only thing I can convert it into, moles of barium chloride. All right, and the way we convert from grams to moles, if we look at our units here, it's grams to moles. So barium chloride is 208.23 grams per 1 mole. Now, if we look at our equation, I don't want to find out moles of barium chloride. I want to know how many grams of this barium sulfate I could produce. So right now I'm in moles of barium chloride. And if we look at our reaction, it's a 1-to-1 relationship. 1 mole of barium chloride would produce 1 mole of barium sulfate in this reaction. So that is a 1-to-1 relationship, right? And I know I'm in moles of barium sulfate. I know that 1 mole of barium sulfate is 233.4 grams. 1 mole of barium sulfate is 233.4 grams. So if I solve all of this, this one's really nice because it's just 1, 1, 1, and on the bottom those 2 ones. So really, we did all of this work, and we're going to just do 233.4 divided by the 208.2. So when we do that, we will get 1.12 grams of barium sulfate. So if I have 1 gram of barium chloride and as much sodium sulfate as I want, I can make 1.12 grams of barium sulfate. That means basically that 1 gram would limit my production of barium sulfate to 1.12 grams. Now let's look at sodium sulfate. If I have 1 gram of sodium sulfate, and it's going to be the exact same process, except for I'm going to use my molar mass of sodium sulfate, 142.05 grams. That will convert me from grams to moles of sodium sulfate. And now, again up here, 1 mole to 1 mole, just a 1-to-1 ratio. That'll be different if you have different number of moles, but in this particular case, it's just a 1-to-1 ratio. 1 mole of sodium sulfate would create 1 mole of barium sulfate. And our last step is going to be identical. 1 mole of barium sulfate is 233.4 grams. So if we solve this one, and again, it's nice and easy. We're just taking the 233.4 divided by the 142.05. And this one we get 1.64 grams of barium sulfate. So if I had 1 gram of sodium sulfate and as much barium chloride as I wanted, the most barium sulfate I could produce is 1.64 grams with 1 gram of sodium sulfate. So now if I had 1 gram of each, this barium chloride is going to limit my production of barium sulfate to 1.12 grams. So my limiting reactant is going to be barium chloride. Barium chloride will limit me to producing 1.12 grams. If I had a little bit more, I could get this 1.64 grams because I can make 1.64 with that much sodium sulfate. But I can't quite make that much with only 1 gram of barium chloride. So that's going to limit my possibility of making barium sulfate. All right, so now let's look at the second question. It said if 1 gram of barium sulfate is produced when we actually do this experiment, what is my percent yield? So this is just in theory. We did a whole bunch of math to say this is how much we could produce if 100% of everything reacted. But if we were to actually do the experiment, this is saying we produced 1 gram. So we produced 1 gram in actuality. In theory, we could have produced 1.12 grams. So what is our percent yield? Well, it's no different than like, a 9 out of 10 on a test or something like that. this is what we got, this is what we could have got. So if we just do 1 divided by 1.12, that gets us roughly 0.89. And as you guys know from calculating a grade, multiplying that by 100 would get us a percent of 89%. So we'd have 89% yield if we actually did this experiment and got 1 gram when we could have got 1.12 grams.